Today I wanted to show you all how I take a bottle of zebra mussels like this and measure how big they all are using computer software. So kind of nerdy, but I had some people ask, so I'm going to show you. So we're going to be working with this bottle here, which I've already dumped into this sieve and let them dry over the course of like 24 hours because they're a lot easier to work with when they're dry. So I'm going to dump them all from the sieve into this tray here, and there's 30 squares in this tray. And the reason for that is we want to randomly select the zebra mussels that we are measuring because that eliminates bias. So like if I wasn't using this tray, I would instinctively pick the biggest ones because I want to know how big they are, right? So there's it's a 6x5 tray. So like I said, 30 squares. And the way that I select my mussels is by using two six-sided die, or dice rather. So like here, I would go to square 4, which is here, and I would get all the mussels out of that square to be. The reason why I'm doing a subsample is because it would take me so long to hand measure all the mussels in that sieve with a pair of calipers. So if I know there's going to be more than 200 or at least 200, I always do a subsample just because it saves me time and it doesn't affect the average. Um, so I'm measuring shell length, and doing a subsample gives me roughly the same average shell length as measuring them all by hand. So yeah, it just saves me time. So let's go ahead and dump these out. I tap it on the sides just to get them all like that. See, there's still some stuck in there, so then I'm gonna have to, it's hard to do with one hand. So I just scrape them all, do that. And then once I have them all in the tray, I'm gonna spread them out as evenly as I can just by eyeballing it. It doesn't have to be perfect. I think that's all the, let me turn my light on. There we go. So yeah, that's all the mussels. I'm gonna spread them out. All right, so now they are all roughly spread out evenly, and I'm going to randomly count 200 of them. So I'll see you in just a second. All right, here's 205 randomly selected zebra mussels. I put the extra back in the bottle here. I forgot to mention that this also helps us estimate how many are in the bottle to begin with. So it took me 10 squares to get 205. So if we divide 205 by 10, that's 20.5. And then we multiply that by the total number of squares, which is 30. So 205, or sorry, 20.5 times 30 gives us 615, roughly, zebra mussels in the jar. So now we just go ahead and pour out our 200-ish zebra mussels, and then I will arrange them to take a picture of them. So I'll show you that in just a sec. So this is the final product. I just try to make sure that the shells are not touching each other, and I spread them out as evenly as I can. And then I put this little ruler in there to help me measure on the computer. So I will take you there now. Also, this is how hot it is in my garage right now. So here we are inside now, and over here on the right I've got the original image, and then over here on the left is Image J, which is the software that I'm using. So Image J is actually this small little window down here. So the first thing that I'm going to do is I'm going to make the Image J image into 8-bit, which makes it black and white. And then the next thing I'm going to do is I want to set my scale. So here I've got this little line drawing tool, and that's why this ruler is important, because it helps us set our scale. So here I've zoomed in on the ruler, and I'm just going to draw a line from 130 millimeters to 140 millimeters. It doesn't matter. It doesn't matter which section I choose, just as long as I choose a 10 millimeter section. And then we'll go over here to Image J, Analyze, Set Scale, and our known distance is 10. The unit, oops, the unit is in millimeters. This is hard to do one-handed, but I'm going to do it. So now image J knows that that is 10 millimeters, and it can determine how big all the muscles are. But first, we have to remove all the background, everything. We have to remove everything other than the shells. And to do that, I'm going to go over here to Image, Adjust, and Threshold. Boom, it turned all the muscles red. So here, I only want this part here on the left. I don't want any of this crap on the right. So that already looks pretty good, so I'm just going to click Apply. Boom, turn them all into black and white. So now we need to remove the ruler, and we need to remove all this other stuff that's not muscles. And that process actually takes quite a bit of time, so I'm just going to do it and I'll show you the final product. All right, so here's my final product. So now I can go down here to Image J and click Analyze, Analyze Particles. See how it says size millimeters squared? So that gives us the area in millimeters squared. We want to go ahead and show the outlines just because I like having the outlines. Everything else here should be good. So I just click OK. Boom, a whole lot of windows pop up. I don't care about this one. I don't care about this one. This one I just save as overlay. And then here's our actual results. So I'm going to go ahead and save this as here. So I'm going to do results, the name of the lake, or the abbreviated name of the lake. This is plate. Sorry, this is boring. This is plate. Sorry, I had to check what plate it was. It's plate 1, and this is the west plate. So, and we want to make sure we type .csv, because that makes it into an Excel file. So I'm going to click Save. And see, these are the outlines I was talking about. So it gives you, it outlines every single muscle and it numbers them from top to bottom. So yeah, let's open up our data. So here's our data. There were actually 212. Sometimes it's hard to get an accurate count because sometimes the small ones are inside the big ones and stuff like that. So yeah, here's our data. The only column I actually care about is this ferret length here. And ferret is just like the maximum length from one point of the shell to another. So it's very similar to hand measuring with calipers, getting the like maximum shell length. So the average shell length of all the mussels in that bottle was 10.45 millimeters. And if I sort them, so I can go to data and I can sort. Whoops, hold on, let me, 1 second. So the largest mussel that we had was 18.44 millimeters, and then the smallest one we had was less than a millimeter. So yeah, they can range in size quite a bit. But yeah, that's how I measure an entire bottle of zebra mussels. Thanks for watching.